All right, so welcome to the afternoon forging session. My name is Dave Custer, owner-operator of Fiery Furnace Forge out of Columbia, Kentucky. I've been blacksmithing now for about 19 years. This is all I've ever done. And I started doing decorative type stuff when I was younger and kind of fell into the tool market a little bit later on. And that's what I've been doing ever since. So for about 12 years now, I've been doing tools almost exclusively. And we still do occasional stuff, you know, custom stuff that comes in, little oddball stuff. But tools is what we kind of specialize in, tools for blacksmiths. And so we build tongs, hammers, punches, chisels, forges, power hammers. That's kind of what we do. Now, having said that, I've demoed tools a bunch. I've demoed a few other things as well, but mainly tools, hammers, and tongs. And since I started making tools, there's a bunch of other people that make tools now too. And so a whole bunch of people now have demoed tools and hammers and punches and chisels and tongs and stuff. And so I've been demoing that a little bit, but every once in a while I like to break away from that and try to give you something new, something that you haven't seen. If you've already seen a pair of flat jaw tongs forged or a Brown Brazil style hammer forged. Now some people are like, well, when you come to a demo, just do what you do in your shop. Well, okay, we'll send a semi-truck and we'll load all the tooling up and bring it up here and I'll show you what I do in my shop. Because we're set up kind of for production, for doing that type of stuff, and there's not real practical. I can show you how to make a hammer, how to make a pair of tongs, but at the anvil, not how I do it in my shop. So that's kind of the case there. And like I said, everybody's kind of seen all that a lot of times already. So today, what I'm going to be demonstrating is this little hook here. And so, you know, if you're just starting out blacksmithing or you've been blacksmithing for a while, hooks are kind of one of the fundamentals. One of the things you start making early on, teaches you tapering and a little bit of scroll work or the start of scroll work and some isolation for your tab, for your screw and that type of thing. And so what I want to do is I want to demonstrate a hook, but something a little bit more down the line as far as skill set, okay? And so this is a simple project, pretty simple project, but it takes planning and forethought, okay? So it's not necessarily that if you're a brand new beginner, you can't do something like this, but you're gonna have to try to think about it with your setup and your tools and plan it out and figure it out. So there's kind of two things I want to focus on with this project, and the first one is stock calculation. And then the second item that I want to kind of focus on with this project is forging square corners. Okay, so the first one, stock isolation. What am I talking about? Well, our starting material is going to be 1/2 by 3/4 flat bar. Okay, and this is our finished product. We have two pieces of 1/2 by 3/4 flat bar. That's our finished product. The cross section of our finished project is about 1/4 by 3/4. Okay. So we're reducing the stock dimension by 1/2 in order to generate these nice crisp corners throughout this piece. And so what we need to do when I was talking about stock calculation, in order to get a certain distance between these two corners, I need to figure out how much volume of material I need between these square corners before I start forging. Otherwise, I'm not going to be able to control the proportions and size of the finished product. And so, while, like I said, while it's not difficult, you just have to do some forethought and some planning on this item. So I have a drawing here that you can look at. It's very rough. I'm not good at drawing, especially 3D type stuff. And so this is just kind of a side view of my two individual pieces, the hook and the crossbar here. And I've got a bunch of numbers on here for different stock calculations. I did this two different ways at the shop when I was trying to figure out how to do it. I did it out of 5/8 square, and I did it out of the 1/4 by 3/4. The 1/4 by 3/4 was way easier, so we're going to stick with that, okay? But you get different proportions, you can kind of play around with it. So what we have to do is we have to figure out how long of a distance we want between these two corners. So I drew the hook out by the profile, full scale. So I can take and measure these points, okay? And so I measure those points, and I say, okay, so I want, say it's 2 inches between these 2 points. And then I want a cross section here, a finished cross section of 1/4 by 3/4. So I have to do some math to figure out what the volume of that cross section is, okay? So in this case here, my finished dimension is, we're going to just go with 2 inches because it's easier. The actual dimensions of this are a little bit different, but this kind of gets you the idea. So we want 2 inches of stock times 1/4 inch thick times 3/4 of an inch wide. We have a volume of stock right there of 0.375 cubic inches of stock, okay? So that tells us how much volume we need to forge that length between those 2 square corners. So we got to figure out what the volume of our parent material is, our starting stock. So our starting stock is 1 inch of that stock by 1/2 inch by 3/4. So our cross-sectional dimension of 1 inch of parent material then is the same, 0.375, because we're taking 1/2 by 3/4 and we're trying to make it into 1/4 by 3/4. So it's going to double in length. That's a very easy calculation. Now that's all I'm doing. And I'm trying to figure out how much volume I need to create these isolations, okay? So what I came up with for the way it's drawn roughly, for the way this is made, and this is fairly close. We can look at it here and kind of, so the distance here across the top on my drawing is 2 3/8, and my distance there's, it's not perfectly square, but one side's about 2 5/16, the other side's about 2 3/8. That's pretty darn close, you know. Now, if you're making a window grill and you got to fit into, 300-year-old masonry or something like that, you're going to want to do this real tight and make sure that all your math is perfect. Okay. This right here, that's the fun part about a project like this, is you can shoot for good dimensions and good math, but if you miss it just a little bit, it's not the end of the world. Okay. And so my dimensions there, the proportions that I have by calculating the stock that way is accurate, and I ended up with what I wanted. We test this here, the height here. That one's a hair under 2 inches, and my finished dimension here is actually longer. See, it's it's basically 2 3/8 there.
When you are going from point to point, outside, mm-hmm. and you're outside here,
yep.
You're overlapping that cube in that corner.
Yep. Mm-hmm.
Does that account, or how do you?
It does. So that's the best way to measure stock when you're trying to do volume calculation is you measure off the center line of the stock, not outside corner to outside corner, or outside corner to inside corner, or inside corner to inside corner. It's better to measure center of corner to center of corner. And you'll notice on my drawing I have little dots here. Yep. Center of corner to center to corner to try to figure out the volume calculations there. Now, that's where it gets a little squirrely. That's kind of the typical rule of thumb for the upset square corner. We're not doing an upset square corner, we're doing a forged square corner. So it could be a little different. And this is where you have to kind of play around with it and see, like Clay Spencer says, test piece, test piece, test piece. If you have a theory in mind, make a test piece and see if it works. And like I said, this right here is not a critical component, so who cares if it's exactly right on the drawing unless you're going for a very precise proportion, okay? But that's the general idea. Stock calculation, trying to figure out. Same thing with the crossbar here. This particular profile here, trying to figure out that and the spacing that you want here. And then that's going to play into, can you get that on your anvil or not? Or do you have to make special tooling for it, okay? And so your stock calculation may be different so that you can account for your tooling or however you want to do it, all right? So that's a little bit on stock calculation. You can go home and play with that, but if you want to end up here, that's how you start with a parent material and get to there. You got to do that calculation. All right, so what I have here, 2 pieces of steel, the hook bar and the crossbar. So the hook, 1/2 by 3/4, and it is 7 3/4 of an inch long, okay? The crossbar, 1/2 by 3/4, and it is 6 3/8 of an inch long, okay? And what we're gonna do is, we're gonna lay out, I've got marks on here already, but we're gonna lay this bar out with some center punch marks so that we know where to start our square corners at. All right, so for this particular one, for the hook portion here, I've got about 1.1 1/8. For this flat section here, I got about 1.16. And for this bottom section here, I've got about 1 inch of parent material. You know, and that's all based on whatever volume calculations I did, you know, to try to get that cross section with certain distances between there, you know. Now, the length here could be my volume calculation is off, or it could be my hit with my fuller was off and the isolation was a little bit weird. And it also has to do with where you bend your corner on the hammer, whether you're accurate on actually where your mark is. So there's some play there. I put a mark on the end, 3/4 of an inch of stock on the end to create my finials on the end. That's what I'm doing, all right? So there's that. The center bar, I measured the center of the stock, and I need about 5/8 of an inch of material in the center of the stock to create this right here. All right, it doesn't look right. At home, I did not trust the calculation, and this actually ended up a little bit bigger. So my drawing corner to corner, outside to outside, is about 1.25 inches, and I've got about 2 inches. And it was 3/4 of an inch of parent material. So it's weird. You know, like I said, test piece. You got to do test pieces. So we're going to go with my calculation, which is 5/8 of an inch between those center punch marks, and we want 3/4 of an inch on the end. All right. Now, the only other thing here I want to point out is, and this goes into planning this project out. You got to look at where these square quarters are at. These two square quarters are on the same side of the piece of stock. This square quarter is on the opposite side of the piece of stock. Okay, so I put my center punches, 2 on one side and the other one on the other side. So we're going to have to flip it. Okay, so you want to keep track of where you're isolating material. What we're going to do is we're going to take this bar and we're going to chop it up. And once we chop it up and divide out, this portion here is for the hook, this portion here is for the flat, this portion's here for the drop. Once we make that division, which would be like the first heat that we do, you're not going to be able to change that. So it's got to be accurate. And once you make those isolations, you're just kind of stuck. Okay, so that's got to be right. Same thing with this. Got our 2 center punches in the middle. These are on the same side of the bar because these 2 corners are on the same side of the bar. All right. So we'll start heating here. I'm going to work both of these pieces at the same time. That way we can kind of get through it. At home, without talking, this is about 1 hour and 45-minute hook, start to finish. That's the second time through. Third time through, I could probably cut down to maybe 1 hour and a half without talking. You know, talking, and a lot of times I demo, I'll heat the piece up and then kind of show it to you after I've finished a heat or two, so that way you can kind of follow along. And then it takes me longer to reheat each piece. And but that's kind of like if you want to set goals for yourself or whatever. Like I said, that's the second second one of those I've made. First one out of this particular stock. That's an 1 hour and 45-minute project. So you kind of get on it, and it's not too bad. Most of it's done by hand. I've done a little bit on the hammer. I'll try to show most of it by hand, so if you don't have a power hammer or a press, you can do it at the anvil, you know, for the most part. There's a couple of parts that are a little tricky on an anvil, but they can be done. All right, we're going to start on the finial side of both bars. So we'll start and kind of start roughing this area in, roughing this long taper in here. Okay, we're not worried about the square corners yet. We got the center punch marks on there. That's fine. But we're going to start making these isolations. Now you'll notice that the cross section here is not 3/4 of an inch. So we're going to need to fuller down. All right. Now obviously you can have a guillotine tool or a spring fuller for this, and that's nice. But we're going to just do it at the anvil. We got our 3/4 inch mark there on the end. Come over here to a radiused corner of the anvil. We're going to carry that line across to the other side. And we're only hitting on 2 sides right now. I'm using the flat face of my hammer. I'm letting the anvil be the fuller, and my hammer is spanning both of those lines. So the anvil can act as a fuller and the stock is supported by the hammer. All right, so that's created a little isolation for that finial on the end. All right, now what we're going to do is we're going to start forging, kind of roughing out this stock between this center punch mark, that'll be my first square corner, and that fuller right there. Okay, we're just going to start roughing that stock down. Do the same thing on our crossbar. And you want to be very careful with this. You want to establish that mark, and then you want to make sure you transfer that mark 180 degrees across the bar without sliding up and down the anvil. Okay? Those marks really need to be straight across the bar from one another and not kind of stair-stepped. They don't have to be perfectly on your 3/4 inch mark. We can be a little off there, but they need to be in the same place on the bar. All right. Same thing there, okay? You want to do this on a fairly radiused edge of the anvil. This right here is kind of minimal for this. If you have too sharp of an edge, too sharp of an edge on your anvil, or a rough edge that's been kind of broken or something like that, it's going to pinch that stock and it's going to create all kind of problems. You want nice, clean corners. All right, so like I said, we're just going to start roughing this bar out here. So I'm just grabbing material, pulling it out. I'm kind of staying off of my shoulder that I created there, that fuller mark. Staying off of that, I'm not hitting it. Definitely not hitting this parent material out here on the end. If you hit that, see how it bent it? Okay, and if we don't correct that, then the finial will be off center. If we go to correct it and hit it the other way, and we do that for the next hour and a half, you'll have a 3-part hook, because that finial will be on the floor. Yeah. Then we'll have to go into forge welding. All right, so right now we're staying off of that. We're going to clean that corner up, but right now we don't want to be hitting on it. Temperature on that just a little bit? Is that a thing that's possible? More gas. Now, we're forging tapers. So, cross section here, 1/4 by 3/4. Cross section here is not. Okay, it's still about a 1/4 inch thick, maybe a hair less, but it's definitely not 3/4 of an inch that direction. So how do you figure up volume for that? And the way I've always done it, and there may be a more technical way of doing this, but figure out the largest part of your taper, figure out the smallest part of your taper, figure out the length, and half of that is your volume calculation. You figure out the cross-sectional volume of that middle point, and that's the average overall. And that usually gets me pretty darn close. Now that'll be different depending on how you forge a taper. If you forge a taper that starts out big like this and swoops down really small, and then is really, really small the rest of the way out, that's not gonna work because you don't have a good average. What you're gonna need is a nice, clean, smooth taper that is consistently getting smaller and getting larger towards each end.
Okay, I got to set about 1950, or do you want it hotter?
It's looking like it's running pretty good now. Yeah, a little bit better. All right, so this is our hook bar. Gonna find the center punch mark so we don't make any boo-boos there, and start forging this taper out more. We're just hogging material out right now. I'm using the corner of the anvil and a rounding hammer to fuller that material out. Now, I got here towards the end of the bar. I swapped out to the flat face of my hammer, and I'm walking my hammer blows up to that shoulder and then rotating. And I'll show you what that's doing for me here in just a minute. All right, so I don't have it down to finish dimension, but I reduced that shoulder quite a bit there, all right? And what I'm doing is using the anvil to get tight into the corner, and then I'm just getting close with my hand hammer on the top side. All right, close as I can. Then I rotate. If I stay on one side, the anvil's always gonna be accurate, and my hammer blow is always gonna be a little off. And it's gonna push that bar to one side. But if I do it a little bit here and immediately rotate and do a little bit on the other side, it keeps it in the center. It's not doing all this stuff right here, okay? And I can walk up and get a nice, crisp, clean corner on that finial there, all right? Same thing on this bar here. I'm gonna go ahead and start working this shoulder. See that hit there, I hit the finial just a little bit, so I overlapped my blow too far. And that's gonna happen, but you wanna try to avoid it as much as possible. Now, at the end of every heat, I'm going through kind of with the flat side of the hammer and just smoothing things out a little bit. Not 100%, but a little bit. And that way I can see where I'm at. Now I'm still really thick there, okay? And I have a target length, I think of about 4.5 inches that I want between that center punch mark and my finial. Right now I'm at 3.5. So I can pull another inch of material out of that right there. All right, so I could just leave it rough from hogging it out, but it's gonna be kind of hard to see exactly where I'm at. So the first 3/4 of my heat, rough it out, move as much material, gets a little cooler, just kind of smooth it out a little bit so you have an average idea of where you're headed, okay? Just stretching that out. Getting pretty close there on the end to where I want to be at. Still a little thick, but close. All right, and my center punch mark for my first shoulder is right there. All right. Now our target length here for the hook bar below this first square corner is like 8.5. That's what we're shooting for there. And about 4.5 on those crossbars. We're gonna get it close, Then we're going to start isolating out those shoulders for the corners, because that's also going to move some material and make that length grow. Okay, so like I said, we're going to take each individual segment of this hook and get it maybe 50, 60, 75% there, and then move to another section and get that 50, 60, 75% there. Kind of do that all the way through as much as we can, and then go back and refine that last percentage and make sure that way we try to hit our target measurements, okay? All right, so I think we're pretty good there. We're about 4 inches from our center punch mark to the shoulder here. So we need to grow about a 1/2 inch, but we got to drop this shoulder down and walk that taper back to blended. So pretty good. One thing I did forget, and you'll kind of see why it's a challenge, we'll do it right on the other side, is I really should have tapered this end first. It's going to move around a little bit because it's thin right here. We can control that, but it would have been better to taper that first. So that's what we got so far there. We'll go ahead and try to put the taper on this end, and then we'll flip it around to the other side, match it up. So we're about a little less than 7 right now. So we're kind of going to just walk this taper down, not very aggressively. And even though I'm not done, you see I'm going ahead and kind of chamfering the corners just a little bit. Just like I said, so I can see where I'm at every stage. Make sure I don't have any real low points that I'm going to have to deal with or high points that I'm going to have to deal with. Same thing with that. Really should have tapered that first, so we'll go ahead and do that. And that's about done. So we'll taper these ends, flip them around, we'll start isolating for our corners. Also, you'll notice this past heat, up until this point I haven't done this, but this last heat I shouldered one side, okay? So it's flat on the back side, shouldered on this side. It is shouldered on this bar, the hook bar, shouldered on the same side as that, okay? And it's kind of important because when we flatten this out, that shoulder is going to go away, but it's just better for it to be on the same side, in my opinion. I mean, you can make either way work, but you know. All right, so what makes this difficult to do after it's already been shouldered and tapered, this is a really short, blunt taper. So it wants to push that small portion of bar back and forth. And so I'm just coming in here trying to control that as best I can. I'm going to hook that shoulder that I created a little bit and kind of knock this back so it doesn't fish lip too bad. I can hit the corners too. I'm just trying to bring that down to a point. And this isn't really a leaf finial necessarily, so it doesn't have to be like a real fine point. All right, so something like that right there is what we're after. And again, we're 4 inches from our shoulder to shoulder, so that's where we want to be right now. We want that to grow just a little bit. So there's that. So we'll flip it around to the other side. This is the crossbar. This is the hook bar here. We're going to do the same thing on it. Try to bring this down without it bending back and forth on that bar. And if the fish lip deal really bothers you on a project like this, you can kind of pre-grind it a little bit and kind of help you out there. But, you know, for this particular project, I'm not super concerned about it. All right, so that's the hook bar. So this one here, we're going to flip around and start putting our shoulder isolations in. We're going to put all of them in at the same time. And again, the idea is I could take and forge this one shoulder 100%. And then move down and try to forge the next one 100%. The problem is, the second one may affect the first one, and if I've already forged it 100%, I don't have any more material to forge. Whereas if I forge it 60 or 75%, I've still got 25% of material to play with to blend a missed hammer blow in or adjust something that is off a little bit. So we want to go about 75% to finish dimension on all of these areas, and then start dicing up the material between them and forging it out. You know, so. This could be done at the anvil. Isolating these shoulders could be done at the anvil. What you would do, use a fuller like this, a little handheld fuller. You can have one on a handle. This is just a handheld one here. Lay your stock flat on the anvil, and you're fullering not on the center punch mark, but on either side of it. And you're going to create, the center punch mark to be on this high point, and you're going to create these radius slopes down to eventually your finished dimension, okay? And what you're doing is you're isolating that extra material for the corner, because on a square corner, the dimension diagonally across the corner is wider. So if a square corner in 1/4 by 3/4 stock is thicker than a 1/4, so you have to have more than the parent material in that corner, which is why we're using 1/2 by 3/4. It gives us that bulge of material by forging this way. So there's 3 ways to make a square corner. This is a forged square corner. So we're taking and we're dropping material down on either side, creating the bend, and then that extra material becomes the corner. We can do a Haberman square corner bend, which is just a tight bend, and you peen that material out. So the outside of the corner is very thin. The inside of the corner is the parent material thickness, and it's a tapered corner. It's a very aesthetic corner, but it's not applicable in all situations. Then there's the upset square corner, where you make a bend and you upset the stock both directions back into that corner. The upset square corner is the hardest, in my opinion. The forged square corner gets you a true parent dimension square corner all the way through, but you have to start with drastically larger stock than 75% of your finished dimension. And then the Haberman square corner, the forged square corner, where you peen it out, like I said, it's nice, but the outer part of that corner is kind of sharp as compared to some of these, and so there's applications for all of them, okay? I'm going to use a fuller under the power hammer to create my isolations, but it's the same idea. You lay the stock on the anvil, go either side of your center punch mark, and forge that material down. right, so there's the first square corner off the taper right there, isolated down. This material will be brought down to blend in. And then these two square corners here are opposite of each other. So that's going to be a corner and that's going to be a corner. And we got to try to forge that material in. And then that square corner there and then that square corner there. Okay, so that's... So there's the first square corner off the long piece here with the finial. Square corner there. Then we swap sides because these square corners are going to be opposite sides from each other. So we swap sides. There's our second square corner. There's our third. And I went ahead, took that fuller, and kind of dropped this material in just a little bit. That way I don't get confused about where to put my fuller and smash something. They ain't supposed to be smashed. Yeah.
You don't have to do the run start switch, it's bypassed right now.
Do what now?
You don't have to do the run start or the power.
Oh, just leave it? Okay, okay. All right, this is our crossbar. I'm gonna go ahead and put the taper in first this time. Be a little easier. This is for the finial on the other side of the crossbar. It's a little easier not to get the fish lip or not to get as bad of a fish lip because I can hit it a little harder because the stock is supported, so. All right, so there's a little taper. You see the center punch mark there where I'm going to put my shoulder, so that'll be the next heat, and then I'll start drawing that material out, okay? Pro tip, if you point at hot steel long enough with one of these and put it in your back pocket, it will be hot. Questions so far? Anything at all? All right. It's a really basic forging project, nothing super earth-shattering to it. But it, like I said, it's kind of neat because you have to kind of think your way through it. You know, kind of plan it out, work progressively through it, and develop the structure. So that just kind of refined everything, bringing it down closer to dimensions, still thicker than a 1/4 inch, which is good. Like I said, you want to walk it in, don't just do all of it at one time. So,
Flatten your corner.
yeah, flatten that corner just a little bit, going long ways on the die there. And it's still got some thickness there, but yeah, that I did smush that just a wee bit that you see there.
Yeah.
I've still got enough material there, but it's just something to be aware of. And every time I do that, that fuller, so this is like a 1/2 inch diameter fuller, something like that is what I'm using. So it's rounded on one side with about a 1/2 inch radius, flat on the other side. And so I'm using that to kind of drop those corners down and then forge between them as well. And again, you could do that at the anvil here, and then use the edge of the anvil to fuller those areas between those two shoulders. Now the two shoulders that are on the same side of the bar, that's going to be a lot more tricky because they're on the same side of the bar, so you can't rotate it and clear the corners of the anvil. You can make a block to go in your hardy hole that's very narrow, specifically for that. You can use a hand fuller to kind of peen it out from the top You can also use a narrow part of the horn as long as it fits between those two shoulders. That's the idea. All right, crossbar again. We're going in and fuller on our center punch mark. Try to get these fuller marks lined up. All right, so just the same thing we did before. You know, a little isolation, get those corners straight across from each other. When you establish that first corner, you gotta hit the stock. And instructing, you know, people are, the guy right there, you need to make a hit hard enough where you can feel it catch on the anvil. And what they'll do is they barely tap, they can't feel it, they move and they barely tap again. They just create a bunch of little bitty taps all over the place. Okay, so that first blow, get it lined up best you can, sink it with one blow so you can feel it. Now you can make it deeper after that, okay? But you gotta catch it in the first blow. Then when you feel it, lock it in, rotate the stock without slipping. That's the hard part. So lock it in, rotate, hit again. All right? But if as soon as you feel yourself slip, stop and re-register. You really got to take your time and get that control on the anvil with the hammer in order to do this. Now again, you can do it with a guillotine tool, spring swage or spring full or something like that. That's a little easier. The idea of my demo is you got an anvil, you got a hammer, you can do this. Might take some practice, you can do it though. It doesn't take a whole bunch of tools to do it. Okay, that's the point. All right, let's so all I did with that heat really is just go reestablish that corner first thing. So when you make a mistake like that, stop trying to keep going everywhere else. Go back and try to reestablish that point. The only thing different with that point where I smashed it is you'll notice it's wider. So these are kind of more narrow points. That one's a little wider. The material is mostly still there, but it's just distributed just a little differently. It's not really going to affect anything. That corner may not be as crisp when we initially bend it, but the material for the most part is still there where we can get it crisp, I think, without any problem. So that's kind of what I did with the goal of that heat, was just to kind of reestablish that, get myself back on track. Now what I want to do is take this taper here, it's pretty much finished here, and I want to blend it with that and get it, 90% there, what I want to do, okay? This bar here, we're going to start hogging out that other half. And you could do this with that little 1/2-inch fuller at the power hammer, it'd be a little faster. But this size bar is kind of fun to work with. There's enough material where you can actually make something, but there's not so much material that it's hard to move by hand. Yeah, I slipped. I went to hit, and I slipped, and I stopped. And I slipped a very, very small amount, but I felt it, so I stopped and reset. And it's always important to do that. People got to get in a tizzy about, oh, the metal's hot, I need to come out here and just hit it. Well, no, you need to hit it where you need to hit it, And so if you can catch yourself like that, you want to stop. Now, a couple months ago, I didn't really slip. I just overlapped the piece I was hitting, and I knocked my front tooth out, which was real fun. That happens sometime. But you want to try to catch those slips like that, reset, make sure you're locked in, register where you need to be, and hit. All right, so I'm going to work this long taper up here to my first square corner, get everything blended in, and drop down close to finished dimension. So I'm kind of looking and seeing where the stock is thicker. I'm trying to forge more aggressively in those areas and just walk it in to where I want to be. I got that shoulder facing down and staying off the edge of the anvil. If I bounce up on the edge of the anvil, it'll be the same thing as what I did there. I'll hit that corner a little bit and squish it down. So I want to be careful about that. We'll see where we're at. And we're about 8.5 there, so we're pretty much ready to clean that up. So I'll heat that whole section up. We'll bring that down pretty much to finish, planish it all out real nice. All right, back on the crossbar. Just gonna hog some material out here. Try to get it down pretty close. Our other side's about 4 inches, so we want to make sure this one matches. It's right at 4 inches too, okay? So we're ready to drop down for these 2 square corners and then finish all that out, all right? So this is just the flat side of the hammer. And I'm just going to clean everything up. Try to get a nice, smooth, consistent taper. I'm going to hit the corners. All right, so it's a nice clean, this is what I was talking about. If your taper kind of swoops in and is basically then the same size all the way down, it's gonna be way longer than mine. Also, if it's basically straight all the way down to here and then dives in real quick, it's gonna be way shorter than mine, okay? So it depends on how you lay your stock out, how you forge, how your volume calculations are gonna work for this, okay? All right. Now we're going to go ahead, we'll finish up the finial on this side, lay in a little chisel work, and then we'll flip it around and finish out all the forging up at the top here. 2 ridges there. And I went ahead and kind of dropped some of the mass down there, and then I'll go in by hand and kind of blend all that in, okay? We're still, our finished dimension idea is about 1/4 by 3/4. This right here is still 3/8 of an inch thick. So I've still got material to work with. If something's a little bit off, I've got stuff to play with. Versus if I just drop it down to 1/4 inch and then look at it and be like, oh, something's a little off, I don't have anything to do. I don't have any material to work with. All right, so now I still don't quite trust my 5/8 to 5/8 there. So I cheated out just a little bit. So I did it on that one too. It ended up wider, so. And we're only talking about 1/8 of an inch difference, but I still don't trust it. It doesn't look right. All right, so to start on this finial, I'm gonna use the round side of my hammer. I'm just gonna drop some material down here. All right, that's pretty good. I'm gonna go to my hot cut. Good sharp hot cut. And I wanna hit pretty hard on this. And it's gonna move some on you. Well, that moved a lot. You can play your angles a little bit and reduce that. That just wasn't the right angle. I'm gonna reheat, but I put 4 grooves in there. The first side you're gonna wanna hit hard. Make them deep. And the reason why is when you hit the second side, you're gonna shorten them a little bit. So you want the depth on both sides to end up being the same, all right? I did it according, it's like a measurement that I thought was from the end of the bar, because you can measure from the end of the bar to a measurement, or you can measure from the previous measurement to your new measurement. And I couldn't remember exactly, so I did it one way. I'm like, okay, that ain't right. Trashed that bar, grabbed a new bar. I'm like, actually, so I just misread my notes, folks. Here's how you do it. I did it about halfway through. I'm like, nope, the first one was right. So it's a little bit more awkward to me to demonstrate that way, but at the same time, it's real-time problem solving. You kind of see how it runs. So. All right, so this is the hook bar. I'm putting the marks in the second side of the finial here. I'm gonna take a look at them. You wanna make sure the line is deep enough on the front side of the finial. And I'll show you what that looks like here in a minute. I'm just kind of tilting it towards the front side and hitting it again. I'm going to adjust the second side just a little bit. Straighten everything out. And it's a little wonky trying to do that because you're doing those marks on a taper and you're hitting a taper on the top side. So you got to try to just do the best you can. But you see how I kind of chase those lines around to the front side just a little bit. It doesn't go across the front, but I kind of pushed them around to the front. And the reason why is, we've made this about half the size it's going to be. Did the marks. Now, as we forge it, those marks are going to open up and grow. So to make them more pronounced. They don't look like much now, but when you forge it, they're going to grow. If that mark does not kind of wrap around the front side will forge, overlap the mark on the back side, and you won't see it. Okay? So you got to make sure that you're not holding it at an angle and just cutting the back side. All right. All right, so I was pretty close to finish dimension. I'm just taking the flat side of the hammer. I'm gonna just draw it out a little bit, planishing as I go, not too aggressively because we were so close. Don't want to overshoot. Looking for 4.5. I wouldn't cry if it was 4 3/4. 5 might be getting a little bit long. And again, that's the fun fun part about this project. If it was 5, it'd be okay. You know, you just have to play with your bends until it looks right. If you undershoot your measurement and you can't figure out how to get to your measurement, I can't help you. That's kind of what we do. All right, so we're at like 4 5/8 from the center right there. That's, you know, and a nice clean, smooth taper. Corners are taken off and everything. You know, don't forge it square to your measurement and then take your corners off because you'll overshoot. You know, so. All right, we'll flip around, do the same thing on the other side there. And the bigger thing here is make sure both sides are the same. 4 1/2, 4 3/4, 5, 4. You probably make all of them work, but if one of them's 5 and the other one's 4, you can make that work too, but you know, might be a little off. All right, so quick word on anvil placement. I've always been round horn to the right. This is the reason why. I'm working on 2 bars at the same time. I can work on the 1 bar here, and I can still work the other bar over here. And if I miss that far, I kind of deserve my finger to be on the floor at that point, okay? Maybe you shouldn't be forging. Bird watching out here is a lot of fun. Flip the anvil around the other way, which is fine. If you like horn to the left, that's fine. Flip the other way. I can't do that now because I'm going to cut here and then need to go here to forge. And I'm swinging right over the top of that hot cut, okay? So that's why I do that. Some people don't realize that and then walk up and cuss me out later because I forge with the hot cut in the anvil. My hot cut's over there. My anvil's right here, okay? This is a small anvil, still pretty tight, but it can be done. Otherwise, between every single heat, I'm going to be popping tools out back and forth, and I'm never going to have the right tool ready to go. So that's the way I like it. I also like it because if I'm doing something on the horn, I'm here on the horn, I can see the horn, versus if the round horn is here, I have to completely walk around my anvil over here. That's, you know, that's personal preference. That's how I started. The main thing for me is the hot cut. All right, so we're going to take this finial now. Cross peen does a little bit better for this, I think. And we're just going to basically spread it out widthways. And this one had a pretty good fish lip in it. Again, because I did it before. All right, I did the finial after I did the taper. So I couldn't hit as hard, so it's got a bigger fish lip in it. Now, fortunately, on this project, it's not really going to hurt anything. And I'll show you why here in a minute. Clean all this up. That fish lip blended right in, okay? But there is a pretty substantial fish lip on the end of that bar. But it blends in with that particular texture, you know. So not the end of the world on a project like this.
Nice.
All right. That's kind of a cool little finial. Pretty easy to forge. Something a little different than a finial scroll or a half penny or whatever. You know, just something a little different. So that's good on that side. We're going to flip it around and start chopping all this up, putting all the material and getting it close to finished dimension. I'll do the chisel line after we do the rest. The later you can do the chisel line, the better, because you're not going to get scale build up inside of it. You know, I don't brush. You can brush every heat. It drives me crazy. I always tell people if you're a demonstrator, you don't like your crowd, you brush this way. If you do, you brush this way. But it's just easier not to brush, you know. So I don't typically brush. I might brush a little bit towards the end, you know, just kind of knock off the outer layer, make a little cleaner finish. I have a vibratory tumbler. I don't brush anything. I forge it, throw it in the vibratory tumbler in 45 minutes. It looks pretty, so, you know, I like that. All right, so this is the second side of the crossbar here, and I'm just wanting to forge it down to match the first side. And it's pretty close, so this is all with the flat side of the hammer, not being very aggressive with it. I want to try to walk it in, check my measurement. I'm about a 1/4 inch short of the other side. So take one more pass, both sides. Really try to tuck in this corner here, clean it up. Take the corners off. And then flatten it out. We'll see where we're at. All right, it's 4.5. The other side's like 4 5/8. I'll take one more real light pass on it, and that'll true it up. All right. So this one here is about an 1/8 inch shorter than that one right now. So we'll pull that out of there. All right, let's take a look at what we got here. So I've got all these shoulders here. So what I'm going to do is kind of go through every little stage here and forge it down just a little bit. Dress the edges back. Now I can come over here to the horn, kind of pull this section out between these 2 points. And then we want to maintain our 3/4 inch cross section, so I'm always coming back to the anvil and kind of dressing that back down. All right. You know, you could, a couple different ways. You could come in here, be easier with a straight peen, but you could come in there, you know, and peen that out as well. Straight peen, right-handed diagonal peen, left-handed diagonal peen, or cross peen will all work, and I sell all of them. All right, so all I did was I went just a little bit in each section, just so I could see them a little bit more. All of them are still too large, which means I have material to work with, and I'm just working everything proportionally so I can watch it grow proportionally. That way, if something's a little off, I can leave a little bit of material here in order to make it match that proportionally speaking, make it look good, okay? Again, we're not trying to fit some sort of 300-year-old masonry archway or something like that, you know. So if we got to do some tweaking, we're okay. It'll be all right. And we're getting pretty close. That section right there is about it's a hair less than 5/16. That section, pretty much 5/16. And then I'm going ahead and kind of establishing the taper for my hook here. Now you could leave that all true dimension, make it look like a fishtail scroll instead of a tapered scroll, but you'd need more material for that. So, you know, again, kind of planning out how you want this project to go. All right, so crossbar, we only needed 1/8 of an inch, so go real light down through here, both sides. Crisp this shoulder up here. That'll pull a little bit out. Flatten that out a little bit. Just working all sides evenly, and then go back down on the corners, planishing it out. All right, that got us 4 5/8 right there. We're right there, you know. That's all we needed. So, let me see, we got 4 5/8. All right, so now we're gonna go ahead and do the finials on both of these, and then we'll figure out what to do with this middle portion. Now I can use the corners of the anvil to work on my isolation. But what I don't want to do is bite in there too deep. So you see this bite right here.
Yeah.
That's perfectly fine because there's my center punch mark. Now I've got a ton of material right there. But if I walked that and bit right there, it wouldn't work. It would make a real thin area. Right, the corner would be protruded all the way out, but it'd make a really thin area right behind the corner, and there'd be no way to put that material back there. Okay, so you see this right here. That's the bite of the edge of the anvil. It's okay right there because I've got a lot of material from that corner to where my center punch actually is. But if that line was right there, that would be a problem. Okay. So you see this here. That's the bite of the anvil. I did a little bit here as well. There's a little bit here. Now, that's okay there because there's a material between that line and my center punch mark. But if that line was right there,
No way to get it.
like I said, the material's still there on that singular high point, but there's no material on either side of it when I go to make this corner. And so what happened is I have this thin area. It'd be hard to bend the corner because it'd bend where it's thin, first of all. And then once it's bent there, you're not going to be able to push material back in that corner. There's a thing called a MIG welder for that. Yeah, if you want to go that way. Okay. Thank you. All right, so we're pretty close on all of those. We're about ready to make our bends, really. I'm going to go ahead and refine this taper here. Now, here's another thing. So I talked about earlier, I want this nice, long, consistent taper. Doesn't need to swoop, doesn't need to bulge. This one, on the other hand, looks really nice if it swoops. So it goes from this nice, thick corner here and swoops down into a nice, refined, elegant hook. Okay, so that's a time where the general rule for a taper is straight, consistent sides. Establish that general rule, learn how to forge to that point where you can consistently reach that point. But then once you learn the rule, you know when you can break the rule. And in this particular thing, we're going to use breaking the rule to create an aesthetic feature on our hook. That's kind of the general rule there, rule of thumb. All right, so finials on the other side here. Just using the rounding hammer to kind of pull a little bit of material out to about half the final dimension. Take the hot cut. And I do 4 lines on these here. You could do 3. You could probably fit more in. Just kind of depends on what you want to do. Like I said, the first side needs to be a little deeper than what you want because when you flip it over, it's going to forge that down just a little bit. Okay, so you're going to lose a little bit of it. So we want to create this swoop here. So we're coming over here to the end or the horn here. Use the rounding side of the hammer and the horn and create a little bit of that swoop. And then just clean everything up. All right, so see how I created that? It kind of swoops down, gets smaller real quick, and then I got a consistent taper after that. All right, we'll take that and knock the corners down, clean it up. You could go square, octagon, round on it if you wanted to, I'll leave it mostly square with a little bit of material chamfered off the corners is all.
What was the mark off on there for the hook?
For the hook portion, that was 1 1/8 inches.
You're out to what now?
So from the center punch mark, almost 4 inches. Now most of the material is still there in that corner. Or I'd say most, a lot of the material is still in that corner. So the actual hook, volume-wise, probably only 3/4 of an inch of actual material. Now when you try to get these lines in just the right spot and move this thing around, you'll see what I do is I'll stick it up there and I'll do this number here. And what I'm doing is I'm walking that down the edge of my chisel. So I'm isolating the pressure on one single point of the chisel. I rotate the bar, rotate this way, and it walks it. And I can very minutely adjust where that chisel is going to be. But it's you do that. And by the way, I'm sorry. Like halfway through these. But if you just try to set it on there, you're gonna be all over the place. So you find an anchor point and keep a singular anchor point. Same thing when we go to do our chisel work. Keep that pressure on there with the chisel and walk it around. Okay. A lot of people will try to take. Same thing with the chisel. Try to take a chisel and just set it on the stock, and you can't ever get it where you want it. So. All right, we'll just do some cleanup work on this hook. And I'm chamfering the corners almost all the way to where my square corners are going to be. You can't go all the way there because there's that radius swoop right now. We'll deal with that whenever we finish those square corners. And we want this hook to be nice. If you're going to do just a regular finial scroll, rat's tail, whatever you want to call it on the end, forge that thing to a nice, fine needle point. Teaching and people take a 3/8 bar and make a hook out of it. They put a taper on it about this long, and then they try to make a finial scroll out of that. And you end up with a 7/8 inch diameter finial scroll, And yeah, I get it, you don't have the control of material and all that kind of stuff, but with time you want to develop the skill set to get nice, clean, fine tips on these scrolls. All right, so I'm going to flip it around. We'll go ahead and do our chisel line here. And I think the next thing to do is going to be both of our first two 90-degree bends will be the next part. All right, this one here, that shoulder, that inner shoulder was a little sharp, and you see that it's going to have that line on the front. Now, that's not on the back. So if you put the shoulder on the back, that's what you'd be looking at on the front. So, again, different ideas, different ways of doing it. If you have a good radius edge on the anvil, you won't get a line like that. So, play with your anvil dressing, but also you play out with layout, and, that'll kind of get you where you want to go. All right? While we're on that side, we'll go ahead and punch the hole and do the chisel work there. Yeah! All right, so to to do the chisel work, you don't need it to be crazy hot. You know, a low heat like this going into a black heat's fine. And what I did on the sample piece there was I kind of did a squiggly line chisel on this long piece. So all I'm doing is I'm rocking this chisel back and forth, walking it down the bar, making sure it registers with the previous hit before I hit. And then I'm just kind of rolling it back and forth, left and right across the bar. And we'll walk it up pretty close to where that corner's going to be. And then you're just going to chase it back down and make sure it's a little cleaner than just the first pass. This is a nice way to take a section of bar and very, very easily and quickly give it something that makes it kind of pop. All right.
Makes the light hit it different. Makes the light hit it different.
Yeah, you create those highs and lows. Now what he said was it makes the light hit it differently, okay? One thing that you think about when you're doing this, I don't use a standard chisel, a slitting chisel for this. That is like a 90-degree bevel chisel right there, okay? And the reason why is aesthetically, if you're doing an aesthetic chisel line, your mind does not see depth, it sees width. So by using a real broad chisel, we create a real wide line that's relatively shallow, versus when we're slitting something, we want a real slender chisel that goes deeper. Okay, so it's a minor difference. You can still see the smaller line, but I like that more bold, kind of fatter chisel line as well. So. All right, so I did something a little different on this one here, just to show you. So I did the squiggly line instead of a straight like this, but then I come in with a second line, and I made it look like the second line dives under the first line, okay? And all I did was add a little line, skip a portion, and then jump over to that other side there. And it kind of gives you this woven kind of look.
Flames.
Yeah, and you know, so that's something else you can do to kind of spice it up a little bit, you know. So. I used to do this a lot on pot racks and stuff. You got long sections of flat bar. Basically, all you do is cold chamfer it, and you throw these chisel lines in it, and it really makes it pop. So you see how there's the main chisel line, and then that other chisel line starts there, and it looks like it dives under, comes back, and is there, you know, and on down through it. All right. It's just a round hole punch, pretty small one. Punch about 3/4 of the way through the stock. Ooh, I can actually hit the hammer, or hit the punch. There we go. So you punch about 3/4 of the way through the stock from the first side, and then you flip it over, there'll be a mark on the back side, and you punch it from the back side, finish it out. Now, you see the little marks on there from the Pritchell hole? So you can dress your Pritchell hole where your Pritchell hole is radiused, and you won't get that. You could also be smart, punch it from the back side and flip it over and finish it from the front, and that doesn't happen. Again, little things like that to think about, you don't think about. And then it would, you know, and of course I could forge that out too, but you wouldn't have to worry about it if it was on the back side. So just start from the other side. Also dress your Pritchell hole. But there's just a little hole there for screw hole. So what I was talking about there, start from the back side. Now, I'm going to show you what I'm looking at. So I punched that from the back side. About 3/4 of the way through, I feel the resistance of the anvil. Look at the front side. Now I got a very crisp, clean mark that I can see to line that up. Now you can get your calipers out and do scribe lines and center punch and punch like that if you want to, but the idea with this, we do it at the anvil pretty quickly. So there's the back side there about 3/4 of the way through, and then there's the mark on the front side. That we want to line back up. And you do all that in one heat. The idea is punch 3/4 of the way through. By the time the stock's cooled off, you're ready then to punch from the front side. And you want a cooler temperature when you're trying to shear that plug off. A lot of people will get 3/4 of the way through. Maybe they're not as good with the tongs and all that kind of stuff. It takes them longer. They get 3/4 of the way through, they go back up to a full heat, and they come out, and they have a hard time getting a nice clean shear on that plug because the stock's too hot and it's just stretching. There's two factors that play into that. First of all is heat. Second of all is you got to hit it hard. If you just tap on it, it's not going to shear that plug out. It's going to stretch. And I found this out because I was teaching, and I had a student who could not get a plug. Every time he'd try, that thing would just stretch and stretch and stretch. And I looked at his punch and trying to figure out why things hung up on one side, so I'm just trying to get it to come off there. Trying to figure out why it won't shear. And I would use his punch and it would shear just fine. And he'd use it and it'd big rag back and forth. And it was lined up. So I'm trying to figure out why, and it wasn't too hot. So I'm checking all the boxes, and then I realized he's not hitting it hard. He's just barely tapping it. And it's just stretching that plug. All right, so there's that, and now the marks are on the backside. A little forethought, you know, so. All right, so there's that side. Do the same thing on the other side there. Finish the crossbar out. got a 90-degree V-block here, precision machined, as you can see. It's just forged. Take a big piece of square stock, smush it in there. 90-degree V-block. Again, anvil and fuller. That's all I'm doing. I'm just doing it here because it's a little easier. Okay. But you can do this at the anvil without any problem at all. All right, so our first corner here, we're going to line this spoler up with the thickest part of the bar and drop that in there. So there's the start of our first two corners. Now you see all that mass that we have pushed up into that corner. We got lots of mass. But also look at the back side of the corner, how it's rounded. Okay? Now, I could have used a 90-degree top tool to push that in there. That would give me a crease on the inside, which is okay if the alignment is exactly where I want it. If that sharp crease is not exactly where it needs to be, you can't move it. But with this radius here, I can pick exactly where I want that inside corner to be and then finish that at the anvil or with a block of some sort, you know. But this gets my initial placement done. I can decide if I like it. If I don't, with that radius on the inside, I could go back to that V-block, roll it up in the V-block a little bit and move that corner. Okay, so that inside radius right there is extraordinarily helpful. All right, you see the inside corner is heavily radiused. There's no sharp creases. So there's a sharp crease there. Everything on this side of the sharp crease is always going to stay on that side of the sharp crease. Everything on this side of the sharp crease will always stay on that side. Okay, you cannot shift it. With a radius, you can shift it. Okay. All right. And the only other thing I'll point out here, you'll notice on that first corner, the first corner is the one that I smushed just a little bit, okay, over there on the hammer. You'll notice, see that right there? Very, very slight, but there's a thin spot right there. Now, that thin spot is maybe a 64th over a quarter. Now, if I had forged that all the way down to a quarter, it's going to be a 64th under a quarter, okay? So that's what I'm talking about, walking it in, getting yourself 60% of the way there, and then nibbling off maybe 10%, and nibbling off another 10%, and now we've got like 5% material left there that we can still move and get where we want to get, hopefully, all right? But I'll show you there what I'm talking about, that little bit right there. Okay, so that one little missed blow gave us a little problem there, but since we didn't go too far, with our initial isolation, we still can address that and hopefully completely eliminate that. You know, even that's not super visual right now, so if we can just dress it down a little bit, we'll get there. But that point right there, see that? Created that one little thin spot right there. Okay. We got a thin spot right there that we got to try to address. All right. So. And this is too where it's important when you're doing a project like this, people get caught up in heat, hit, go right back at the forge. Look at what you're doing. Okay, people do this punching a hole, especially on tall stock that's thin or a hammer billet. they get in a tizzy about punch on hammer, bang, 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 bang. And then they're like, oh, it's a little bit off. Well, it's too late. You're 3/4 of the way through the stock already. One hit, remove it and look at it. If you need to move it left or right, you can do so. Same thing with this. You know, a couple hits in, as soon as I came off and come over here, I noticed that one little ridge was a little bit off. So the very next heat, the first thing I did, reset it, make sure I know exactly where it's supposed to be. And then when I make this initial bend, I'm looking at it again. Okay, I've got a little problem there, but I can address that as long as I pay attention to it. Okay, so. All right, this is the crossbar. We got to work on the second finial here. Now we're going to kind of look at where we want this corner to be at in relation to where the material's at. I know I've got that thin spot, so I'm going to drop that crisp inside corner down just a little bit. And see, now I'm actually creating that crisp line with the anvil on the underside. But what I did is I rolled that radius down a little bit to push that material into that thin spot. Okay, that's all I did. We're just going to dress that up a little bit. We'll come up here and kind of do the same thing. We'll figure out exactly where we want to be. And this project here has got some weird angles on it. And you're going to have to kind of move around and find a place on your anvil that will work for what we want to do. Now, you notice right now we're not square corners either, okay? We still got a little bit of thickness right here. That's thicker than Parrot though. We want to be more down to here, so I got to blend that in. But what I did was, that thin spot was right there, so I pushed this over the edge of the anvil and moved the crease this way so that I could then hammer this way and push that material into that spot. So now there's not a low spot there on the top, okay? Looks thinner right now, like I said, because this part's thicker, but we'll blend that. Also, you can just barely see it. That right there is our original center punch mark. Okay? You can see that one a little bit better. That's the original center punch mark. Right on there. So we're pretty much right on target there with those two. Okay? So I dropped in and made a crease there. There's our original center punch mark for that one. There's the original center punch mark for that one. Okay? See the mark there and there.
Hey, you said there was worst corner, upset corner, and then you said there was a third kind. Could you explain that a little bit more?
Yeah, I could show you one real quick. Be easier to show it to you. Here, I'll show you. So we're just crisping those corners up a little bit. Mainly worked on this one. Did a little bit on this one. We got kind of some thickness in here to deal with, but again, that's okay. Our target dimension's 1/4 inch, so you know that's right at our target right there. And we're still maintaining, you know, basically 3/4 of an inch wide. There's the original center punch mark for that corner. There's the original center punch mark for that one. So pretty close. All right. And we're not 90 degrees, and that's okay. You can be open from 90 degrees. You do not want to be closed from 90 degrees. Because if you're closed from 90 degrees, if you're sharper than 90, and you have to open it back up, and then you close it up again, and then you have to open it up again. We have a 2, a 3, a 4-part hook, a 5-part hook. There's a part of the hook over there. There's a part of the hook over there. There's a hammer in the wall over there. So you want to stay open until right at the very end, crisp everything up, adjust it all. Again, is it a 90-degree corner right now? No, I'm 75% there. It's the same. I kind of drill that stuff over and over and over again, but then I see people go out to the anvil and they're like, oh, isolation, 110%. You know, I'm like, no. They're like, well, how do I do to fix it? I'm like, go get a new bar and do it the way I said to do it. So every single aspect of this, I'm trying to go 60, 75, 80% across everything, and then come back and adjust it. Now, there are places in this where we're going to have to go because we're going to start getting some areas we can't get to. And that's where this thing starts getting a little tricky. Now, having said that, if you got an oxyacetylene torch, this thing becomes a lot easier. And I haven't used mine because I wanted to, you know, I'm trying to prep this for a demo here with minimal tools. And so I've done all of this at the anvil, but if you got an oxyacetylene torch, these corners, you can get a nice crisp bend much easier. You can do it in the vise. You know, you don't have to have a V-block or anything. Just put it in the vise, heat the corner up with the oxyacetylene, bend it, and then heat it up with the forge and true it up. You know, so those little toys really make things a lot easier. This is our crossbar. The second finial here, just stretch it out. And you could leave the peen marks in it. You know, there's nothing wrong with that as a texture. I've just been smoothing them out. If you had a smaller chisel, you could make this a lot more fine. You could do sharper curves. The smaller the chisel is, the more work you can do, more fine work you can do. This is kind of a bulky one for trying to do, you know, these overlap lines or whatever, but just kind of show you the idea, give you something to play with at home. All right, so I've got some thicker parts trapped between these two corners, and so I'm just going to try to bring the majority of that down to finished dimension. And we can upset a little bit here. See, I'm upsetting between those two corners, kind of true things up and tighten those corners up a little bit. So, you know, there are some just different angles you can get to on this particular project. All right, I like that pretty good. This corner is not the best in the world. You see there's some material thickness kind of variance there. Not a lot, but you know, it's there. I don't love it, but it'll work. You see the material thickness variance. I could play with it more. Again, if you had an oxyacetylene torch, isolate, heat there, upset. You can do that, you know. I'm not a huge fan of heat and then try to isolate it with water. By the time you're done with that, you're basically out of heat anyway. And I don't like that. Our distance between corners, outside to outside right now is 2 inches, which is, that's exactly what that is right there. So, you know, it's a little bit less than this one here. That one's like 2, that's proud of 2 1/4, almost 2 3/8. So that right there could be, it's the same material mark off, but it could be a little different with the fuller or something like that, you know.
You got to get that hole in there next.
Yeah, got to do the hole. The hole may stretch it a little bit, not much. It won't stretch it that much, but it'll stretch it a little bit. Also, I haven't done the corners too, so, you know. Now the hole on this one, the first one I forged most of the corner work before I did the whole bar and finial. Don't do it that way. That's dumb. All right. You got to punch the hole before you bend this corner because the corner's in the way. But you got to set the rivet after that's bent, unless you're doing it with a torch. Because you can't. Once you start reheating it, you know, it's going to make everything weird. And once it's riveted, you're going to be stuck. So it gets a little. The putting everything together or finishing it up gets a little tricky. All right, then you put a hole in this one. I'm gonna center it up a little bit. There we go. And I'm just eyeballing center. I always encourage people to learn how to eyeball this stuff. Just go to the anvil and do it. You know, I see people spend a lot of time trying to lay stuff out. Develop your eyes to where you can see it and just do it. And it's a lot faster that way. If you can just go to the anvil and guess and get it right, that's it's a little faster way to do it, you know. Keeps things moving along a little faster. Well, there's, you know, hole in that side. All right. So now this one here, we want 1.5 inches outside of corner to outside of corner. And it looks really tiny right now. But outside of corner to outside of corner is already 1 1/8 inches. We only need 3/8 of an inch. That was 5/8 of an inch of material between there. And I cheated a little bit at the hammer because I still don't trust 5/8. It just doesn't seem like it should be enough. Okay. Now I made a tool. The idea of this tool is right here, is I could lay it down and drive this tool into it, and it would help forge those corners. But your calculation and then your forging has to be spot on in order to fit in that. And so 5/8 between those 2 points when you first lay out your center punch mark was what my volume calculation told me to do. And I keep cheating it out a little bit because I just don't think it's enough material. This one wouldn't fit in the tool, so we'll have to see if this one does. I've still got I'm still 3/8 of an inch thick right there. So I've still got a lot of material to move. So it's probably going to be wider. All right, so we're just going to clean this junction up here a little bit. We're going to take all these corners down. Like I said, there's some weird angles in here. You got to move around a lot. And I'm using the anvil to get kind of tucked in behind some of these tight places where I can't get with a hand hammer. All right, so I just planished all that stuff up basically. Just kind of cleaned the corners up a little bit, you know. There's also, okay, there you can see it pretty good there. If you look at it straight on, see how the corner's tilted just a little bit? So when you do a square corner, it's not just a matter of making that square. It's a bunch of different angles you want to look at. So you see that one's a little angled because basically the bar was slightly turned when I did that corner. And you could go in there and dress that up and clean it up a little bit, you know. I'm not going to sit here and fuss and fight with it for 3 hours, you know. Get you the general idea and, you know, kind of you follow along and get it as close as you want to at home. All right, so on that, we got to punch the hole next. This one here, we're going to kind of drop this material down on either side. So I'm just thinning that material out between those 2 points. You can also notice, like, see how that ridge is not square perfectly with the bar, it's a little angled? So that could play into whether or not that square corner ends up good and square in that particular plane. So whenever you lay in your Fuller marks, be mindful of that. Try to get it square with the bar. So you see this one's square with the bar, that one's a little bit more angled, you know. So just, those are all little things to watch out for. See, that ridge there, a little bit angled, you know. That corner is about ready to bend, because we'll bend it and then forge it out a little bit so it will grow after it's bent. See, it's corner to corner is like 1 3/8 now, and we're still in the center there at the thinnest point. We're still 5/16. Yeah. Trust the numbers. All right, so we're ready to punch the hole on the hook bar. And I'm gonna punch a square hole, not a round hole. And that way when you put the rivet in, it can't rotate on you at all. It's locked in a little bit better. And so if you do round, it's not gonna matter that much. It's a 3-point hook, so you know, it's got 3 points of attachment. It's not gonna move once it's mounted. But I'm just doing a square hole just because. And again, I'm just eyeballing center here. And again, there's some weird angles in this thing. You gotta kind of get creative with where you can do what. Like I brought, oh, there it is. So there's our square hole. And that's why I started with this square corner here, and I'm working my way to that final one. If I had started here, getting that square corner in there becomes a lot more difficult. And you don't really want to do the square corner, I don't think. You probably could make it work, but you don't really want to do it before you bend these 2 corners on either side of it. Because then you're going to have a thin section of bar that's going to want to move around on you and distort. And then if you've got to come in here and dress the sides up, you know, you have a rectangular hole at that point. So just little things to think about there. Stop and look at what I'm doing, make sure I'm on track before I go too far. I get some more heat, but there you go. Start of those. Okay. It's the same thing as I did on the power hammer. A little easier on this bar because it's shorter. It balances on your V block. But, you know, with a couple blocks of steel, you see that? A couple blocks of steel you could set up where it balances the bar out and stuff like that, you know. So I let it kind of pull that up because otherwise it would have hit this corner on the hammer as it came up. So I kind of let that open up a little bit so I can get that started and I can dress it down on the anvil the rest of the way, all right? So, but you see how much material that leaves in those corners there to play with and really forge it out there, okay? Do what?
Will it fit in your tool?
Fit what tool now?
Will that fit in that block?
Oh, well that's for the crossbar. Yeah. This one won't. No. That one was sized for the cross block. That was the idea behind that tool. So. So there's that. Center punch marks for those two are kind of gone because, like I said, I kind of cheated out with my fuller, just maybe a 1/16 of an inch on either side. So you can't see the center punch marks anymore. As far as the tool goes, we're wide. You trust the math, even homeschool math. Yeah, and that's, like I said, this one here is wide too. This one may be a hair narrower because I didn't cheat it out as far. It'll be close, but you know. But yeah, the measurement that I had for 1.5 inches or whatever it was across the corners was 5/8 of an inch from center punch to center punch. That's not the material between it because it's going to slope down. It's from the ridge to ridge, 5/8 apparent material. And that should fit in that block. We'll never know. Yeah, test piece, yeah. And this is where, I mean, the block I made just kind of as an idea real quick. This is where a double horn anvil is really nice because it allows you to get in small areas like that with a square corner. I switched over to a double horn a few years ago and I've really enjoyed it. All right, so we're going to just kind of straighten this up just a little bit. And this corner on this anvil here is really sharp, so I want to make sure we're in the right spot before we go dropping this corner. And really sharp is fine, but you just can't move it once it's there. All right, so that right there, you know, we're pretty close to the drawing right there as far as size. This one's a little longer. That one ended up longer too. So something's off with my math on that particular measurement. Now what we can do, if I can hold on to it, set that there. Still use this top tool to kind of crisp up our corners on the inside just a little bit. And you can also use a radius tool and leave that radius on the inside of those corners too. They don't have to be sharp on the inside. So that just crisps that one up a little bit. On this side, we'll do that side next. I'm just working all these little angles, trying to get in all the nooks and crannies and clean it up a little bit is all. All right, so that's pretty good there. We can bend this hook around. And again, you know, our stock distribution through all this could be a little bit better. A little thick here, a little thin there. Pretty consistent up through here, and then it jumps out a little thicker there, you know. So you kind of fuss with that stuff, work on your layout and whatever, but pretty close. We got square corners. Again, you're going to be looking at it from this direction too, so, you know, it's not the end of the world. As you can see, like, that's a little thick, and then a little thinner up through here, you know. All right, so we'll bend the hook around. We're just going to crisp the other corner up here on this one. And then try to clean up the corners as best we can. Finish size a little closer to that. You know, like I said, again, the 5/8 I think is about right, but it is what it is. And then you notice I'm trying to keep these things fairly symmetrical. I'm letting them sweep because that's going to be the final shape, so might as well. I don't need them to be straight. Just need to work on the corner. Stock distribution here is a little bit better. You know, it's probably a little thinner here than it is there and there, but close. And again, that's your plane that you're looking at anyway, so, but you know. We need to punch a hole in that. All right, so we want to put a little finial scroll on the end here. Make sure we do this in the right direction here. Hang on. Yep, we're good. I'm just going to straighten the hook out just a little bit off center, just try to knock it over there, because we're going to be looking at it this way here, so that's where we want it to be aesthetically the best. So there's that. All right. All right, so we're going to flip it around here and heat up this section so we can start our curvature for it and get that long sweeping curve. A short section of 3/8 square or 1/2 inch square. Just 10, 12 inches would be fine. Probably 1/2 inch would be better. All right, so this is our crossbar. We just want to punch a hole, square hole in the center of it. That hole's where a little forethought pays off too. If I had punched from that side and then I flip it over, now I don't have a clearance hole that I can get to. Now I use this bar here. This is a bolster bar to be able to punch the other piece out, so you could use that if you got one. But it's just got to fit in there if you do it that way. Doing it here first, I can put it anywhere I want to when I flip it over. You know, little things like that make jobs like this a lot easier. Sometimes you see them and other times you don't till it's too late. All right, so now we can start kind of finagling all this around with this bar, get everything lined up where we want it to be, okay? Now, as drawn, the hook bar is about, I think it's about 4 inches off the wall. Yeah, right at 4 inches off the wall, which means this back bar then needs to be about 3.5, 3 3/4 to the outer face off the wall. And it's easier if you got like a big table or something to do it on, but I just do it on the floor or the anvil. This is where having a clean taper begins to pay off, because if you got a lumpy taper, it's going to get real hard to get the bigger parts to bend consistent with the smaller parts. Okay, so there's kind of the start. That's probably still stepped off a little far. Take one more pass. If your taper's consistent, your heat's consistent, and then you move consistently here, then you will naturally get a nice, clean, consistent curve for the most part, and have small little things you got to edit. If your taper's all lumpy, and you hit here, and then you move up here and hit, and then back down a little bit, and then back here, and then back here, there's no consistency to that approach, and so you're not going to end up with a nice, clean, consistent bend. That got us pretty much all the way there. We're still stuck off too far from the wall here, so we're 4.5, maybe 5 right there. So I still need to bring that in a little bit, but everything's moving consistently. Okay.
3/8 square. That'll work?
Yep, thank you. All right, so there's one side there. And you could try to heat up both sides, I guess. Maybe hold it in the middle, try to do both at the same time. But, you know. We can put this on the floor, put our hammer where our screw is going to be, and then measure. We're a little short, but our square corner is also a little bit off. So come in there, clean that up, and we'll be real close. And this can be, you know, so it can be fine-tuned cold as well. Doesn't have to be hot to be able to make these finer adjustments here. So, you know, we got a nice, long, clean curve. I like that. Now, you look down here, our tab is kind of angled. We need it to be straight to mount to the wall. But other than that, we're pretty good. So we can do with that. All right, that's pretty good right there. Yeah. That's pretty close. All right, so we're gonna let this sit here cool. Try to get this other bar tuned in pretty close. almost 3.5 there. All right, so we're really close. This bar here needs to stand up a little taller. We'll take a heat and do that real quick. Try to heat both sides up, because right now it's pretty even. So we'll try to heat both sides up and adjust both sides at the same time, evenly. This is where, you notice here, these pieces are, the profile's constantly changing. There's finials on the ends, there's square corners, there's all these intersections. It's real hard to get a pair of tongs on. This is where having a cross V-notch in a pair of tongs is super handy, because I can put that corner right in that cross V-notch and hold it, and it's actually supported then in both directions, okay? Versus having, if you just had a straight V, you'd have to go all the way through and out the side here, and you only have support in the one direction. And so this allows me to get into some angles that I can't get into with just a straight V-jaw pair of tongs. So all of the tongs that I've made, the smaller bolt tongs like this that you use for products like this, have that cross V-notch. Now, I break that rule when I got up into like the 1.25 inch, 1.5 inch, 2 inch size tongs. Anybody here forged any 2 inch solid square corners lately? You have? Okay, all right, we're good. One person. So those corners, you're obviously not dealing with stock like that. So typically when you're holding big stock like that, you're holding it on the end, straight in line. You're not holding, offsets and weird stuff as much. If you need to upset a big thick piece of bar like that, you grab a pair of billet tongs. You don't want to use a cross V-notch anyway, because it's not going to support the stock as well as a pair of billet tongs would. So that's kind of why I don't do it on those bigger ones. But the smaller ones, it's super convenient. All right, so I need to make this taller. So I'm going to come in here and just adjust these angles a little bit. Try to do so consistently. Knock these tabs back down flat so they'll sit flat. All right, that got us a little closer. I'm gonna call that good for now until we get our rivet made. All right, so while that cools, we'll make our rivet. I'm gonna make the rivet out of 1/2 inch square bar. Of course, you could use a manufactured rivet for this. I'm just going to forge the rivet off the end of the bar. So I'm going to make a tenon on the end of the bar first. Now, I was talking to a guy yesterday about tenon tools and stuff and how they're made and whatever. What I'm going to be doing here is just free-forming a tenon on the edge of the anvil. You want a nice, clean, crisp corner of the anvil to do this, and you got to take your time doing it. If you try to get in a hurry, you're going to hit your corners, hit your shoulders, and it ain't going to work. But you can get a pretty clean tenon doing this, and then you use a little monkey tool or bolster to crisp the corners up the last little bit. You don't have to have a butcher, you don't have to have a sizing tool, and you don't have to have a swage. You do it all freehand at the end. And you can do it freehand on a power hammer as well, as long as you got good dies that line up. And like a radius like this right here, too much radius. You actually want a real tight corner for this particular thing. So that's just some things to keep in mind. Now, who asked about the third type of square corner? That you? Okay. Third type of square corner while we're waiting on our tenon bar to heat up. So the type of square corner that I just did, I'm calling it a forged corner. So you have stock that's this thick and you take it down around the corner and then bend the corner, dress it up. I'm calling that a forged corner because we're forging down from the corner. Then you have an upset square corner. Upset square corner is where you bend the bar and then you hit on the outer corners of the bar like on a vise or something, not on a hard surface, on an open surface, and it upsets material into that corner because we need more volume in that corner. So you're taking a 1/2-inch square bar, trying to make a 1/2-inch square corner, you don't have enough material to do that. So you have to upset the material in that corner. That's an upset square corner. Okay. Then there's a Haberman square corner bend. Named after Alfred Haberman is the guy that was kind of using it. So I'm going to make one of those real quick. But this is what it looks like here. Okay. Now we're gaining width here, but we're losing width there. So it's kind of sharp out here on the outer corner. And so I'll show you how to make one of those real quick. I just got a piece of 3/8 bar in here. So we're going to bend a corner as sharp as we can here over the edge of the anvil. Does not have to be a 90-degree corner, but the corner itself needs to be crisp. All right, so there's a 90-degree corner. It could be more, it could be less. That does not matter. But the actual position of the bend, it does not need to be this long arching bend. It's a tight bend if you're making a corner, you know. You could do a long arching bend and spread it the same way I'm going to do, but it's not a corner then, you know. So that's what you. Now, if you want to make this an upset square corner, what we're going to do is we're going to hit here, and we might come in and hit here, and we're upsetting stock into that airspace. So here, here, here. I can clamp it in the vise like this. And do that. That's the most effective way I've seen to do it. Because you're applying force to both sides at once, so the material has to upset. It doesn't buckle as much. It's better with 2 hammers that are the same size for one, but it can be done. It's the most effective way I've seen to do it. I did this a bunch back in 2010, 11, 12 maybe. And you could do a square corner in 1/2-inch stock basically in one heat that way. An upset square corner. So it's fast once you kind of get the hang of it. I couldn't do that right now. I haven't done it in years. And I'd probably look pretty goofy trying to, it takes practice. So that's how you do an upset square corner, okay? Versus the forged square corner we just did here. That would be an upset square corner. Now I'm going to do the Alfred Haberman corner, the Haberman bend. And then we're going to actually peen material out. So what we're going to do, we're going to take this thickness, we're going to leave it alone on the inside of the bend, but the rest of the thickness we're going to peen out this way. So we're going to gain cross-section this way, losing cross-section this way. All right. Now while we're waiting on that to heat up, I'm going to go ahead and start on the tenon for our hook here. So this is just 1/2-inch square. I'm going to forge a short blunt taper on the end. And then I'm going to start dropping that down on the near side of the anvil, trying to hit with my hammer over the near edge of the anvil. So you notice I'm spending a lot of time trying to get lined up. And I swapped to a smaller hammer because it's a little easier to control. All right, so I'm starting a tenon. So you try to see, I'm trying to create a line with the edge of the anvil and the hammer there that I can drop down and make a tenon out of. Okay, so kind of slow, but again, you don't have to make a tenon tool to do this. You can do it with a forge, anvil, and a hammer. right, so this square corner bend here. So what we're going to do, come out here to the outer edge of the anvil and use the peen of the hammer to draw that corner out. So you see I lost cross-section that dimension. I gained it in that dimension, okay? That's what a Haberman square corner bend is. Now right now, it's not a square corner, it's kind of bulge. So we can dress that back down and make it look like a square corner. So when you're looking at it in this orientation, it looks practically like a square corner. When you look at this direction, it changes cross-section. And it has a good aesthetic look to it. It's very strong, and it's much faster and easier than an upset square corner bend. So there's a lot of applications where it's a very good solution. I'm going to cut this off because it'll be easier. With the gas forge heat, it'll be easier to hold it with a pair of tongs than it will be to have my hand so far away on the bar. All right, so one more heat on this square corner bend here. So just go to the edge of the anvil, true it up, clean up the corners. All right, so I can pass that around there. It's getting pretty close. But you see, I mean, I got a pretty clean corner for freehand. It's not a tenon tool corner, but it's pretty clean for freehand. You know, so I didn't have to go out there and make a butcher block and then a tenon swage and a sizing tool or a monkey tool. Nothing special about that at all. Just freehand on the edge of the anvil real quick. That's what I'm going to use, yeah. Mm-hmm. Yep. that's kind of the point. That little bolster block, that's a piece of 1/2x1 mild. I use that same square punch to punch a hole in it. It's roughly the same size as that. Super simple tooling. Nothing complicated to make this, you know. That V block can be made out of a piece of angle iron welded into a piece of C-channel. You don't have to forge it. You know, you can weld that. So super simple tooling for a, you know, a fairly, not a complicated project, but an involved project, you know. All right, so we need this to fit in that hole. It does, that's good. Hopefully it comes back out. But we also need to fit it in these holes. So that fits pretty easily in that one, that's good. And it fits pretty easily in that one, okay? Get a little hang up in that one. Now when we go to put this together, you got one shot. Now if you got oxyacetylene torque, you can still head it over, but we're going to use the forge. If all you got a forge, you got one shot, you're done. If you got to heat this whole thing up, I mean, I guess technically it's possible, but it's just going to be a pain because everything's going to move. Okay, so we want to not heat the hook components up again. We're going to be done with that. So, we got that forge to fit. It needs to fit in there easily. It doesn't need to hang up when we go to assemble it, okay? Now we got basically a 1/4 inch thick cross section per piece. That's a 1/2 inch total. We need probably a 1/2 inch or so of tenon to head on the other side. So we need about 1 inch of tenon in order to fit through there. So we'll cut this off to the right length so we don't have any extra. Swap the battery out. Just double check it in these holes. Make sure it's going to fit in there pretty easily. I think that's pretty good. So we're going to heat it up now and cut it most of the way off of the parent bar so that we can head the rivet. And we don't need much material. We need, you know, 3/8, maybe a 1/4 inch, something like that of parent material cut off above that shoulder. So not a lot. And you could do anything with this. You could paint it out. I've got this little flower punch I'm going to use. So we want to cut this as close to all the way off as possible, but we want to leave it on the parent bar. Now you notice how clean the cut is. That cut needs to be real clean. Thank you very much. That cut needs to be real clean. If the cuts overlap and you end up with a cold shut, you're gonna have a cold shut right in the face of your little rivet there, okay? So nice clean cut, walk it all the way around the bar, cut nearly all the way off. Yeah. I did that one time on a, I did an auger. No, I made an auger, and the little screw on the end, I flattened it like a spear point, a little tiny thing like that, and then I twisted it to create the screw, and it'd feed right into it. It was really, if you ever want a really fun project, it might be a good demo sometime. Make an auger. There's a really good YouTube video, because there's two of them, but there's one really good one on YouTube. I can't remember who did it, of how to do an auger. That is a fun and a very challenging project.
A lot of filing at the end to get the gears. To get the cutters on the outside.
Yeah.
A lot of filing.
Yeah. Might be too. Yeah, we'll have to do a second on that. But I just kind of seated that down. But you notice there's no rags in that face. That's what we want. Nice clean cut. If you don't have a clean cut, you'll end up with a dirty rivet there. Okay. Oh, it does. Wow. Yeah, it does. I'm a good blacksmith. Look at that. All right. So I tried to make that tenon about an inch long. It's about 1 1/8 inches. And the reason why, I measured from the shoulder 1 inch and cut it. Then when we set it, it's going to grow just a little bit. Okay, and that's okay. Just be aware of that.
Sit down the shoulder's got to go in the hole.
So we'll take one more heat, try to get it in one more, drop it in there, and put that flour in there. Now, this is where it gets a little tricky, okay? So I'm trying to do a decorative rivet that's got something pretty on the front of it, kind of makes it pop, okay? But the problem with that is I've got to put the head of that on something in order to peen the backside of that tenon, okay? So whatever I put in the front face is going to get smushed whenever I go do that. I can't cool it off, because by the time I cool it off and get it lined up in both holes and start to paint it, I'm already out of heat. So that's not an option. Plus you're just really fast. I tried on this one to paint it out on wood. Use wood on that front face. The problem with that is the wood absorbs too much of the energy, and only the back side of the tenon mushrooms. The body of the tenon inside the hole does not move at all. So that one right there is loose, which doesn't matter. It's going to 3 points of contact on the wall. No one will ever know once it's mounted. Now, if you're at an art show, it might be kind of hard to sell it on a table because it's going to jingle. Doesn't matter functionally, but that's going to make it harder to sell, possibly. So there's a lot of things to consider there. I don't have it completely figured out on that one. I'm going to try something. I'm going to try to do maybe 2 hits on a hard backer surface. I'm going to try to make my flour really deep. Go maybe 2 hits on a hard backer surface, swap over to wood, and finish it on wood. Hopefully get a little bit of that interior swelled up and get it tight, but then not destroy the decoration on the front. That's going to be my approach 3rd time in. So. right, so that's the flower stamp there. That flower stamp's super easy to make, okay? That's a hexagonal taper. You put a chisel line in the sides of each of the hexagonals and center punch or ball punch the middle. Super easy. And it makes a really nice flower.
So if you had a block that
Yep.
missed the flower but caught 4 corners, you never gave it a flower either.
So you're saying a block that's got a hole in the middle of it for the flower? Yeah. Yeah, technically you might kind of peen the edges out a little bit too much, but if it was, as long as it's a clean circle and you got it lined up. So yeah, I mean there's different ways of figuring out the tooling and how to do this. So there's another high-tech tool that makes this job a lot easier. Available at Fiery Furnace Forge. Big pipe.
Weld that on the inside.
I just welded to the face of the anvil. All right, so what we're gonna do, drop that in there. Like that. What this pipe does, it's gonna allow me to put that hook somewhere. Okay? Be able to peen that out. Hit it maybe, like I said, maybe 2 times. Try to hit it pretty hard, get it to set, then switch over to wood so we don't distort the flower too much. That's the game plan this time. That one I did 100% on wood. The first one I didn't do a flower in, I did a peen texture, but I did it on hard surface and it destroyed all the peen texture. Okay, so different approaches, different results. That one's a little loose. Functionally speaking, not a problem. Maybe make it harder to sell because people are going to pick it up and it's going to feel loose and rattly. You know. So anyway, I kind of want to seat that. So that shoulder's a little high. So I kind of want to do something about that so that it seats all the way in there. Again, if I had access to this, I just stick it in there, tap, 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 and done. But I don't have access to it to do that. Do you see how the very base of that's sitting a little proud? The easy way to fix that is go to a belt grinder and knock it down. You know. We'll see if we can address that real quick before we set this. And I want to try to get everything laid out because, like I said, got one shot at this to get it actually set and done relatively cleanly. Like I said, again, if you got oxyacetylene, you can kind of touch it up if you need to. At least get the back of it tight. You know, so you can address it that way, but we'll try to get it in one run here. I'm just trying to push this up against the edge of the anvil and let the edge of the anvil kind of size that bottom corner down maybe just a little bit. And that got it a little bit, not 100%. Like I said, go to a belt grinder, you know, clean this up, file. You clean it up just a little bit, get it to fit. But again, I don't like sometimes, especially with simple projects, people overcomplicate them. And you got to have, just go to your $2,200 belt grinder and knock this burr off real quick. Well, for some people that didn't translate. The first book one of the first books I ever got blacksmithed, here's how to make a dinner bell. Get your oxyacetylene torch out. And, like, well, I don't have one, you know. I'm 13. Dad won't buy me explosive gases yet, okay? Give me a break, you know. And so I try to make it, doable. with simple tooling. Not to say you should not buy a fiery furnace forged tire hammer and then a coal ironworks press. In that order. We're going to see if we can set this maybe in here. Get it to true up just a little bit. I don't want to mess around with it too long, but I'm going to rotate it 90 degrees because there's not going to be a way for me to re-index it exactly, so I want to make sure it's going to fit decently in both directions. All right, that's pretty tight. So that'll work. All right, so we're going to heat this up. Take our high-tech tool here. Try not to drop it on our toes. So, get everything set up. Try to be as smooth as possible. I'm going to have this piece over here with me, so when I pull this out of the fire on the way to the end, well, I can try to get that in there. Then I can come over here, drop these tongs, pick this up, place it, and paint it. That's the goal. Another hard part about getting this tight is in order to upset that entire tenon, you want to hit it and hit it hard. But I've got about that much space to work in because of that, okay? And so you gotta get in there with a small hammer and just try to whack it best you can, you know, so. All right. That tenon's too long, but that was maybe 1 or 2 hits more than 2. Right? But the flour was deep, so the flour's still there. We're going to twist it just a little bit. And of course, you know, this anvil here, the pipe's not necessary because it's got clearance, but some of them aren't going to have it. So, just make a few adjustments to it there. Drop this down. That's pretty darn close. Yeah, cool that off. Hang on.
All you gotta do is make 3 square-headed screws with the flour.
Turn it a little bit.
All right, yeah, I want to pass that around there.
That's fantastic.
Thank you. So any questions at all? Yes?
So how would you, if we don't have how would we go about finishing it with just, would you wire wheel it?
So you could wire brush each individual piece just straight off the forge. Get a little heat in it, wire brush it, tweak all your sizes cold the rest of the way. And if you can, on a project that's multiple pieces, clean each individual piece before assembly. Makes things way better. If you're doing fab work or if you're doing forging, either way. Clean each individual piece before you do assembly. So me personally, I throw this in a vibratory tumbler, I walk away, 45 minutes, come back, and I'm like, ooh, that's pretty. That's awesome. A bench wire wheel is kind of my go-to. It will eat you, but so will a knotted wire wheel on an angle grinder at 12,000 RPM. So pick your poison. Bench wire wheel is kind of the easiest, although, you know, if you did it individually, piece of cake. You put it together, whole different ballgame for either the knotted wire wheel or the bench wire wheel. You could hand wire brush with like a fine wire brush and then hand sand with like a 120. And what that's going to do is it's going to take those chisel lines and it's going to make them pop. Because you're not going to sand inside the chisel line, you're going to sand everything. Fire! You're going to sand everything outside the chisel line. Makes the chisel line look darker. It's going to make it pop. And so hand sanded finish looks really nice, but it's rather labor intensive if you're talking about something you're trying to do, a production item, that you're trying to produce for a reasonable price. You just, making one or two on your own, put around your house, that's a really nice finish. The tumbler kind of does the same thing. It hits the high points, leaves some of the low points, and it kind of gives you that highlight. It's not as bright as a hand sand finish, it's more dull, but it's just kind of the same effect. So you can wire wheel or wire brush lightly and then hand sand. That's kind of my preferred finish if you really want to take your time with it. And then oil, I like a linseed oil. I do linseed oil mixed 25% linseed oil, 75% mineral spirits. Makes it real thin as opposed to straight linseed oil. I don't hot finish much of anything. It's very labor intensive, so if you're trying to produce, that's kind of a problem. Hot finish is going to give you a darker finish, and it kind of counteracts the highlights of hand sanding. So you do a cold finish on a sanded finish like that, or a wax or a clear coat, for clear coat, which is good for interior items, works great, holds up good even in like bathrooms and stuff like that for wet towels. Outside doesn't do any good at all. Oil finish is better, but you don't want to do a bright finish on an outside thing, so, context, so. All right, anything else? Yeah.
How again did you make that pattern on the flower?
So, there it is. So this is a hexagonal punch. Might be easier to do it this way. It's a hexagonal punch, and there's a chisel line in each of the flats on that hexagon. And then I did a center punch in the middle, so a center punch or a sharp ball punch. Super simple punch to make, but it makes a really nice flower. Available by custom order through furnaceforge.com. So, want to mention this too. First of all, Coal Iron Works, great job on this event. I have been to a lot of events. This event is very well organized and very well done. Second of all, thank you all for the purchases at the booth. We did really good in sales this weekend, and that's each and every purchase that you made. We really appreciate that as well, because that's our livelihood. That's how I feed my kids, so, and me, and my wife, and the dog. So, thank you. All right, any other questions? That's a wrap. That's a 2-piece hook, 3-piece with a tenon.
How much, if you're making that, you've got 2 hours time, you got $8 in material, so it's all time and your tools.
Yep.
What's the price?
For that hook, so it wouldn't be a 2-hour hook for me.
Hour and a half.
Two more times through, it's an hour hook for me.
Okay.
With a couple tools under my hammers, that's an hour-long hook for me. Maybe less if I'm running 3 or 4 of them at a time, which is what I'd be doing. I'd build 5 of these and then 5 of these. Yep. And then I'd use a factory rivet head and then maybe do the flower in the factory rivet head. I'd make some alterations like that to really cut some time off. I spent 15 minutes on the tenon. Yep. And that's after everything else is done. So that's 15 minutes on its own. So that's probably a $150 hook once I set it up for production in my shop. So, yeah. And it may be set up for production in my shop, so I like it. So, it was originally a lamp in the book that I got it out of. They didn't have a hook on it. The flat portion held a lamp. That's what it was. And I'm like, that'd make a cool hook. So, and now it holds old Coleman gas lantern on my house. Kind of cool. So. All right, well, that's it. Thank you. Appreciate it.
All right, 2 quick things.